Hi, I'm Jamie Jacob, Executive Director of the Oklahoma Aerospace Institute for Research and Education and Professor of Mechanical and Aerospace Engineering at Oklahoma State University. And we're here at AIAA at SciTech. We're going to talk about some of the exciting things that OSU faculty and students are working on here. So just watch for more and we'll see about all the exciting stuff that they're doing.
My name is Anthony Comer, Assistant Professor at Oklahoma State University and Director of the Simulation to Flight Applied Research Laboratory. In my lab, we basically go from simulation to flight, as the name suggests. A lot of our research spans this entire envelope, so we start with the actual design, we then create an aero-propulsive model, then we create a simulation model for real-time simulation, develop a control system model, build it, test it, fly it. So over here we have one of our vehicles. It's a tilt wing configuration that we're flying along with, in collaboration with Dufour Aerospace, a Swiss company, where they're developing a middle mile logistics tilt wing configuration for cargo deliveries. And some of the work that we're doing involves aero-propulsive interaction. So we're actually looking at how these wings, when they tilt, what happens with the flow over the wings, how do we keep the flow attached? That also looks into the control law design. So looking into if we can keep the flow attached, how can we use that to safely control the vehicle throughout all regimes of flight? So a lot of the research interest that I have personally is in flight dynamics and controls. So a lot of work in the control law development, and particularly how the human interacts with the machine. How does the next generation of pilots operate these otherwise complicated vehicles? How can we design a control system to be safe, efficient, and easy to fly for the next generation of vehicles?
My name is Rakshit Allamraju, and I'm a PhD candidate at Oklahoma State University. My research is on inflatable wing design structures. We're coming up with a novel wing that can help for morphing wing technology. Well, inflatable wings can be compactly stowed and they can be instantly deployed just using internal pressurization. So that really helps with like time crunch deployments in many applications such as the Mars plane, where you really need to be stored in a compact area and then deployed instantly on Mars, and other applications like emergency first responders, where they need to deliver emergency aid and they can just carry limited cargo. OSU has a lot of resources that can help us do it, especially with the LaunchPad initiative in Tulsa. And engineers like Kathleen McNamara, who's worked with the Toyota Trina team in deploying the mothership kite for Toyota. And we have the wind wall facility that can help us like design and deploy small wings and test it at like different sizes. So.
My name is Kate Spillman. I am a master's student at Oklahoma State University, majoring in mechanical and aerospace engineering. A lot of my research is dealing with balloons and infrasound, so primarily detecting infrasound signals from high altitude balloons. Infrasound are low frequency pressure waves below the threshold of human hearing. They can propagate thousands of kilometers with minimal attenuation, so things like earthquakes, volcanoes, oceans, all kinds of stuff emit infrasound, and we're using balloons to detect them. One of the big projects is that NASA is wanting to work on is deploying balloons on Venus to learn more about its interior structure. One way you can do that is through balloons and using infrasound. One of the great things about OSU is their faculty in the Department for Mechanical and Aerospace Engineering. I've been able to do a lot of cool things being here as an undergrad and a master's student. So conferences, being able to network with companies, as well as being a part of a FAA meeting, committee to help update federal ballooning regulations. That was a great opportunity to meet people from the industry as well as government officials and work together on that too. And OSU was very instrumental in getting that done. Perfect.
My name is Carson Kelly, and I'm a master's student here at Oklahoma State University. My research focuses into classical control methods about drones and how they handle and how they actuate and their simplification through their research. So we can omit ailerons or we can size them respectively, but also trying to initialize flight conditions through pneumatic launching of those airframes. Finally, I do believe that OSU allows me to really work on that research independently almost, wherever I can kind of learn and make my own mistakes, but learn from those mistakes way more than what I would traditionally if I were to just be handed a piece of paper saying, this is X, Y, Z. So.
Hey, I'm Eduardo Michel. I'm a grad student at Oklahoma State University under Dr. Jacob and Dr. Acevedo. So my research focuses on weather UAS sensor housing design features, primarily looking at what design features or geometries are better. I could provide better measurements across a wider range of environments while helping and aiding for more intercomparability across weather UAS. So that helps a lot for people who are like weather UAS developers. Whenever you design a weather UAS for a specific environment, you could develop with certain features that are comparable another weather UAS that is entire different research objective. And whenever you bring them together, you can have similar measurements, meaning that they could be exchangeable and more comparable against each other. Well, OSU provides a lot of important capabilities of this. We have a lot of and a big pool of weather UAS designs. For example, we have the skateboard, we have the meteor gliders that are a glider launched by a weather balloon. We have the Mediomatic system, and we're also developing newer systems like the Stormtrooper and other weather UAS designs.
Hello, I'm Alaura Kanell, and I am studying the Fire and Emergency Management program at Oklahoma State University. My research is on UAS-based landmine detection with a focus in multi-sensor arrays, specifically using RGB, UV, and near-infrared cameras. So currently around the world, there are over 80 countries that have unexploded ordnance or landmines, and more continue to be placed every day. The goal of my research is to identify what soil conditions are the most difficult to identify landmines and find a way to identify them in those difficult soil conditions. By identifying landmines via drones, people don't need to walk into a landmine field, which is very hazardous. Over 5,500 people die or are injured by landmines every year. So the goal of this is to remotely identify them so people don't have to access landmine fields directly. Two things are very unique. One, we have OAIRE, which does a lot of work with unmanned aerial systems and greatly supports my research. The other is the SINFEX field, which is the Center for Unexploded Ordnance. We have two simulated landmine fields. One is a UXO field, which is unexploded ordnance. The other is a seeded landmine field. Each have well over 100 landmines.
My name is Atkinson. I'm majoring in mechanical and aerospace engineering, master in science, and I work at the Simulation to Flight Applied Research Laboratory under Dr. Anthony Comer. And my research focus is in aerodynamic modeling of subscale UAVs, with efforts to create like a digital twin and have an accurate simulation model and tune control system parameters for flight testing. And we basically compare these aerodynamic models to flight testing. And yeah, my role in that is basically making sure the simulation model, the aero model that I create is high fidelity and comparable to flight testing. The benefit is exactly that, simulation modeling that maybe we can train pilots with and actually create a control system that is one-to-one with flight testing in creating high fidelity aerodynamic models. So this vehicle is a tilt wing configuration. It's a partnership with Dufour Aerospace. It is a two-third scale of their vehicle, and yeah, so proof of concept. It's how do the control laws scale, and also how can we study the inertial scaling, how that affects all like the control system gains parameters, and also the differences in aerodynamic modeling. Yeah, you can actually modify the angle of attack of the wing just through the servo mechanism, right? And you see these four propellers. They actually blow air onto the wing for like roll control or for yaw control in the vertical flight mode. So as the aircraft takes off, you have these ailerons to kind of act as directional control, and then you have a lifting propeller in the back for pitch stability. And in comparison to like conventional takeoff and land vehicles like a fixed wing, this allows us to like take off in like on a dime for tilt wings as compared to like a conventional. You need a runway to take off. So that's one comparison. Yeah, tilt it, sure. You can see the mechanism here. It's a gear. So, yeah.
Like we got it built and everything. I was just setting up the last few days. Entire framework is basically just
My name is James Spencer, and I'm the director for the LaunchPad Center for Advanced Air Mobility at Oklahoma State University. So LaunchPad is a research commercialization center that's working with advanced air mobility faculty and graduate students to commercialize new IP based on advanced air mobility. So we want to create new advanced air mobility systems, including drones as well as VTOLs and other technologies and vehicles, but also supporting those technologies with advanced research. So our mission is to not only create new ideas or IP, but also to work with students and faculty to commercialize those in the form of creating startup companies. So if you are a graduate student and interested in working in this industry and developing new technologies and starting a company, LaunchPad is a place to be. We actually have created a fellowship program, which includes a curriculum of advanced air mobility commercialization practice, working with mentors, industry partners, and other faculty advisors to help students take their ideas and then translate them into productive products and services and companies. And we advise you to join us in our next cohort in 2016, in January of 2026, where we have graduate students that are actually going to start the first phases of the two-phase program. The first phase is about research, so that students are actually going to work on a particular area of advanced mobility that's interesting to them and to their advisors. And once they have developed a research result, they want to actually publish it so that they can share that knowledge with the world. And then once they finish that first stage of the fellowship program, we move on to the commercialization stage, or phase two. In phase two, we work with faculty from the business school using the advanced, communications and advanced AI tools to help these students work on commercialization pathways for how do they get their ideas out of the lab into the marketplace. And that's what we do at LaunchPad. Want to talk a little bit about kind of how do we do what we do at LaunchPad. LaunchPad is possible. There was a $39 million grant come from the U.S. Economic Development Administration to fund economic development using research, working with community organizations like the Tulsa Innovation Labs, who is basically our partner in this public-private partnership for commercialization. What's unique about our partnership is that traditional research labs that take applied research and develop products or services, we're focused not only on advancing research, we're making sure that it's connected to the advanced mobility ecosystem within Tulsa. So we're not only looking at technology, but how does technology provide impact and opportunities for communities in the area where people live. And in this case, it's Tulsa. So LaunchPad is really Tulsa-centric. It supports all, citizens, people in Oklahoma, but its footprint is in Tulsa. And we work, again, closely with the Tulsa Innovation Lab and other universities to not only advance the state of the art in advanced mobility, but also support workforce development and other types of initiatives that support economic development in Tulsa.
Thank you, and go Pokes.